So for this video, I picked out a 7-mark exam question that uses differentiation and stationary points. Now, where this question gets difficult is where you have to solve equations, and I'll show you what I mean by that. So how do we determine the nature of stationary points? So first of all, what is a stationary point? If we have a random curve, stationary points are points in the curve where the gradient is actually equal to 0. So like this point here and this point here. Now these can be maximum or minimum points, and that's what it means by determine the nature. It wants you to determine not only the stationary points, but whether they're maximums or minimums. There's also points of inflection, which I'll just quickly show on the diagram. It's where a curve has an increasing gradient. It stops for a little bit, so its gradient is 0, but then it increases again. Or where it has a decreasing gradient, it stops for a little while and then decreases again. These are points of inflection. So yeah, let's break this question down. First of all, I mentioned a stationary point, the gradient is 0. What gives you the gradient? It's actually dy dx that gives you the gradient. So we're going to find dy dx for this expression and then make it equal to 0. In order to help us differentiate, we're going to first put it into a format where it's easy to differentiate. So 1 over x, we can write that as x to the minus 1. 1 over x squared, we can write that as x to the power of minus 2. And 1 over x cubed, we can write that as x to the power of minus 3. Now that it's in this format, it's a lot easier to differentiate in my opinion. So let's do that. Actually, let's do it here, just so there's space for the rest of the question. Sorry, I keep changing the position. Let's do it here. When you differentiate x to the minus 1, it's minus x to the power of minus 2. When you differentiate x to the minus 2, it's minus 2x to the power of minus 3. And differentiating minus x to the minus 3, well, minus 3 times minus 1 is positive 3. And then x all to the power of minus 4. And we make all of that equal to 0. Now, how do we solve this? Well, to help us solve it, let's write this out as positive power. So it's minus 1 over x squared, minus 2 over x cubed, and then plus 3 over x to the power of 4, all equals 0. In order to help us solve this, let's multiply each individual term by x to the power of 4, because what that will do is it allows us to form a quadratic that we can actually solve. At the moment, it's really difficult to go about solving it. So having done that, x to the 4 over x squared is just x squared, so this first term becomes minus x squared. The second term becomes minus 2x, and the third term, the x to the 4 in the denominator cancels out with x to the 4 that we're multiplying by, so it becomes plus 3 equals 0. And again, to help us solve it, we're going to manipulate it one more time. We're going to multiply everything by minus 1. So it's going to be x squared plus 2x minus 3 equals 0. There you go, that looks a lot better. And solving this will give you the same answer as it does solving this. And that's what I mean. That's what I think is the hardest part of this question, providing you know how to find the nature of the stationary points. From there, we're going to factorize. So it's positive 3 and minus 1 that are the correct factors here. And in that case, when the first bracket equals 0, we get x equals minus 3 gives the stationary point, and also when x equals positive 1. Now that we know the x coordinates of the stationary points, what we do is we need to somehow find the nature. And that's where the second differential comes in, d squared y over dx squared. Let's do this in a different color because, just to split things up, honestly. I like to use different colors. Alright, so d squared y over dx squared is what you get when you differentiate dy dx, so this expression here. Now, a common mistake students make, because this expression can be rearranged to this, they end up differentiating this, but they actually give different answers. It's very important that you differentiate the actual expression that you get for dy dx. When we do that, minus 1 times minus 2 is positive 2, x to the minus 3. This term here differentiates to plus 6x to the minus 4. And then 3 times minus 4 is minus 12. So that becomes minus 12x to the minus 5. Now, you can play about with this a little bit, but honestly, there's no point. All it wants is a nature. And if d squared y over dx squared is less than 0, then we call that stationary point a maximum stationary point. So on a curve, it would be this point here. If d squared y over dx squared is less than 0, we call that stationary point a minimum stationary point. Lastly, if it's equal to 0, then we call that a point of inflection. This rarely comes up, but it does come up, so I did just want to point that in. I'm guessing in this question it won't really come up, but let's have a look. So when x is equal to minus 3, so that's one of the stationary points, we're going to put x equals minus 3 into d squared y over dx squared. So let's do that. Honestly, it's best to just put into the calculator. So I'm just going to very quickly do that. 2 multiplied by minus 3 all to the power of minus 3 plus 6 times minus 3 all to the power of minus 4, and then minus 12 minus 3 to the power of minus 5. That gives you 4 over 81. We're not really interested in the value. What we're interested in is the fact that it's greater than 0. And the fact that it's greater than 0 means that when x equals minus 3, we know that that's the stationary point because dy dx is 0. And on top of that, because the second differential is bigger than 0, that means that... Oh, sorry. This should be a bigger sign. This is a minimum. Yeah, very sorry about that. If d squared y over dx squared is negative, then it's a maximum. If it's positive, it's a minimum. Yeah. Lastly, when x is equal to 1, this one's a bit easier. We don't really need a calculator because, well, this term here just becomes 2. This becomes 6. This becomes minus 12. 2 plus 6 minus 12 is minus 4, which again is negative. And the fact that it's negative means that it's a maximum stationary point. It's a bit like the opposite way around. You'd expect positive to mean a maximum, but that's the best way to remember it. When it's negative, it's a maximum. So it's like the opposite way around. And when it's positive, it's a minimum. And yeah, that's everything with this question. Thanks for watching, and yeah, hope this video helped. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.